Today we're going to be looking at unlocking Scotland's tsunami history. This is an unusual topic for the UK, but as we'll see, there's evidence from the geological past that tsunamis have impacted the UK and Scotland in particular. We're all familiar with the impact of tsunami around the globe, especially in Japan in 2011, and here's a really famous photograph from the time of that impact across the whole of the Japanese coastline. These are caused by earthquake-generated tsunamis. What about Scotland? Why would we be interested in tsunami impact in Scotland? Well, there's another cause that is linked to tsunami generation, and that cause is submarine landslides and landslide impact tsunamis. Just up the coast from here is the Montrose Basin, and here we have some of the best evidence in the UK for tsunami impact. Here on the southern shore of the basin, quiet, fine sedimentation, quiet bird reserve, we have a really unique section. If we look at the diagram to the left, we see a spade, and above the spade, the silver part of the spade, we see a pale grey layer. That layer is a sand layer, and you can see that it's very distinctive within the sediment section. In fact, it's the only sediment section in the whole of the UK where we can see evidence of former tsunami. It may look fairly innocuous, but when we look at the in-depth detail of what this layer is composed of, we see that it's linked to former tsunami. This site is also important in that it's been the subject of many investigations from students, from undergraduate students, from researchers, and also many times it's been on documentaries about tsunami in the UK. If we look in a little more detail, here is some of the very fine features, some of the kind of structures we'll see from the tsunami. They're very small but very unique. They're called flame structures. And here the sand is injected into the finer clays above. We see that there's coarser sands grading into finer sands. These are really very delicate features and something that isn't usually preserved within the coastal sediment sections. So what does this information tell us? Well, taking all of the sediments, the analysis of the sedimentology, the grain, the individual grain size, where it is located in the sediment section, we see that this, plus the age of the deposit, links to the Storegga landslide. The Storegga landslide is a huge event that occurred off the continental slope of Norway 8,200 years ago. And it led to a huge tsunami that impacted the whole of the northern North Atlantic in such the same way that the 2004 Boxing Day tsunami affected the Indian Ocean and the Japan tsunami affected that whole ocean basin. So this was a very significant event. We have evidence for this all around the Northern Atlantic, from the coastline of Scotland, the Norwegian coast, up to Svalbard, and even evidence in Greenland. So it's very widespread. We work with scientists to understand how the wave has translated down the North Sea and it has affected our coastlines. And there are simulations from colleagues I've worked with at the University of York, John Hill. Here he has a particular simulation that shows the impact of waves as they translate across that coastline. If we think about the Shetland Islands in particular, in addition to the tsunami from the Storegga landslide, which is very old, 7,000 years old, we also have evidence of two younger tsunamis. One in the Middle Holocene, around 5,000, and this one here, seen in Jurivaux on the eastern shore of Shetland, which is 1,500 years old, so really relatively young in geological terms. We can look at the composition of that sand, we can map the distribution in the valley, and we can think about what that tells us about that younger event. At the moment, it's still really unclear what the causal mechanism is for this particular event, but it's likely linked to a former submarine landslide. We just haven't found the offshore evidence yet. The middle diagram here shows some of the traditional ways of studying tsunamis. We will take cores and detailed sediments and look at the individual grains within those sediment samples. And we can track what that is doing as we move towards the surface. A typical tsunami would have a really nice fining upward sequence where you get coarse sediments at the base with finer sediments as you rise towards the surface. What we can do now is to look in much more detail. And over the last 3 or 4 years, I've been working alongside colleagues in engineering, plus undergraduate students and PhD students, to really look in more detail at the evidence. And here we use what we call micro-CT, which uses X-ray computed tomography of the sediments to give a three-dimensional picture. And that allows us to look at an individual grain in 3 dimensions, very much like a CT scanner in a hospital, but we're doing a CT scan of our sediment cores. And you can see, looking at the image on the left, the absolute clarity of the individual clasts. Each one of these is maybe a half a centimetre in diameter, and we can see the very great detail as we look at what that might tell us about the passage of tsunami waves in this landscape. This is shown in the colour diagram to the right. Again, a really detailed change evident. Further evidence in YEL shows more information from this micro-CT analysis. We can see things that we can't see with normal grain size analysis. We can see things we can't see with our own naked eye. And here we have a small core, maybe 30 centimetres in thickness, and at the very base you see very coarse grains, and they're all aligned in a certain direction. You see they slope from left to right, downwards, and that indicates the passage of the tsunami wave as it approaches the landscape. We're able to see the distribution of the waves and how they interact with the landscape, what we call the hydrodynamics of the wave. That's just how it behaves and how it transports sediment. And this gives us much, much more information than we've ever had before. And it's really the first time that this procedure has been used in sediments of this age. Why is that then important? Well, with climate change, the Arctic tsunamis are the newest and most dangerous threat from climate change. We see with warming climates and the melting glaciers that sediments are exposed on the seabed. They may be liable to slide and create new submarine landslides. In addition, the retreat of glaciers is exposing steep slopes straight into the ocean, and if they become unstable, they then risk being what we call tsunamigenic. They have the potential to cause new tsunamis. And here in the UK, in the northern part of the UK, in Orkney and Shetland and Scotland, we would be at risk from any event occurring on this margin. This is a map of all of the submarine landslides in the northern part of the Northern Atlantic. It was started by a former PhD student of mine, and it's been worked on in subsequent years. And we see the Storegga tsunami as the biggest kind of red splodge on that map off Norway. But you see the multiple events all surrounding, enveloping the UK on its western margins. We also see events on the Greenland margin. And as Greenland continues to melt at the edges, they will expose more and more new sediments, which will ultimately have the potential to landslide. So although the risks to the United Kingdom and the northern part of the UK are relatively low, with changing climate as we move through the 21st century, the risk from landslide-generated tsunamis should not be underestimated.